So hello guys, today I'm going to try and explain how does Bitcoin actually work. Just a quick disclaimer that this is only for information purpose and not financial advice. So if you want to invest in Bitcoin or any other cryptocurrency, do it at your own risk or discretion. This series is only going to be about understanding how does cryptocurrency and blockchain work. So let's first of all start with the basic definition. According to Wikipedia, Bitcoin is a decentralized digital currency that is without a central entity of control or an administrator that can be sent from user to user. So you can basically read it out and you'll notice that it sounds quite complicated, doesn't it? But don't worry, we'll break it step by step into understanding how does Bitcoin work, what is blockchain, how do transactions take place, and a lot more things. So first of all, let's talk about the traditional payments, right? In traditional payments, we had forms of debit card, credit card, or online wallets, etc. But these things, so for example, your credit card or your debit card is controlled by the bank. Your currency notes, their exchange rate are controlled by the government, or the money you have in your wallets are controlled by the apps that own the wallet. So if let's say you have X rupees in your Paytm wallet, or what if Paytm suddenly starts putting them out as Paytm points? And now suddenly, one Paytm point is not equal to 1 rupee. This control is what Paytm has over your money. So this is called centralized payments. Now it has many demerits and many merits. We'll talk about them throughout the flow. So Bitcoin and other currencies are not controlled by the bank, not by the government, and not any third-party apps. It is truly decentralized, that it does not have a central entity having control over it, right? And nobody even knows who started Bitcoin. There's no hefty commission or charges. So you'll notice that all these banks, they charge hefty fees on your transactions. And this kind of an ecosystem doesn't exist with Bitcoin. There are no hefty commissions, no hefty charges. Another thing about Bitcoin is it is universal. Whether you're buying it from India or buying it from the US, you're buying it at the same rate. So before all this, let's start breaking things down in a very simple manner. Let's assume that there are 4 people, A, B, C, D, who make multiple transactions amongst them and maintain those transactions in a ledger like this. At the end of the month, they meet up at a common place and settle up their debts, right? This is the kind of simple system that you generally see using an app like Splitwise as well, right? You just exchange money with each other and at the end of the month, you settle your debts. But is this system reliable? There are some problems. Number one, anyone at any point can add or delete any lines. What this will mean that at any point, anybody can add a transaction which never happened. So let's say A adds this particular transaction in the ledger. Now who's to verify this, that this actually took place? This means that A has created a fraud of rupees 20 against B. This kind of thing you would notice in your Splitwise app as well, that anybody can add or delete transactions. That means you can add a transaction that never took place or delete a transaction that did take place. If you delete a transaction that did take place, let's say this transaction wasn't fake and B decides he doesn't want to pay here and he deletes this transaction. Who's to control? Who's to verify? So this is a big problem. So the solution for it is that each transaction should be signed by both parties. So let's say if A pays B rupees 20, then this kind of a transaction should be signed by A and signed by B. Also, we will revoke the power of deleting transactions and only new transactions could be added. So a signed transaction, once put into the ledger, it cannot be deleted. Only a new transaction could be added. Seems quite simple, right? But there's still a problem. These signatures are still virtual values. So let's say A signs with his initial A, B signs with B. Who's stopping A or B to copying their signatures, right? So let's say a transaction took place, A pays B rupees 20 and it has been signed by A and it has been signed by B. What A does, it copies the signature of B, puts it here and adds similar transaction multiple times, and hence signatures can be easily copied and it still doesn't solve the problem. Even if these digital signatures were not simple alphabets and some random words, they are still combinations of ones and zeros and they can be copied over. The solution for it is quite complicated, which exists in the current ecosystem. Let's understand it. So each person in the ecosystem is assigned 2 values, which is public key and private key. It is also called secret key sometimes. So these abbreviations become PK and SK. Now, what are these public keys and private keys? So these keys are nothing but combinations of ones and zeros as well. But the thing is that they are combinations of 256 ones and zeros. There are going to be overall 2 raised to the power 256 combinations of keys. How large this number is, for some perspective, 2 raised to the power 30 is greater than 1 billion. From these keys, the secret key is only known by the owner of the secret key, while this key is public, as the name suggests. Now what happens is, for every transaction, let's take a message. Let's say A pays B rupees 20. This is my transaction and this I'll call as message. Alright, to sign this transaction, a unique signature will be generated. How will it be generated? Let's talk about that. So this message along with the private key will be hashed out through a function. The message and the private key, let's denote it as secret key here, which is SK, and this will generate a hash. What is a hash here? It will be a combination of ones and zeros, and the length will be 256. This unique value generated will now become the signature for this particular transaction. And what is special about this is a cryptographic hash function. So a very minor change in the message or the secret key will result in a large change in this value. And since it is cryptographic, in this direction, you can never be sure what it will generate, and hence going back in this direction is impossible. Similarly, to verify the transactions, another hash function is generated which takes the message, the secret key and the public key together to return true or false. This is used to verify a transaction. If it returns true, that means this transaction did take place. If it returns false, that means this transaction did not take place. So this is how signatures work. But still the problem isn't solved. Why? Because even though every transaction is signed uniquely, so let's say this transaction took place, right, and it is signed by the cryptographic number. Even though this signature cannot be replicated, this entire message could be copied and pasted again. This entire message could be copied and pasted again. That means a transaction can be repeated as many times as you want. It can still lead to fraudulent transactions. What's the solution? The solution is quite simple. In the ledger, each transaction is now assigned an ID as well. This unique ID along with the message and the secret key will now generate a new signature. So finally, from my hash function, I will pass the ID, the message and the secret key to generate a hash. Now this entire signature will be finally put against the transaction to verify it, and hence it will be infeasible to forge a signature without knowing the secret key. But still this entire system has an issue. Let's say there were 4 friends A, B, C and D, and they wanted to meet at this particular place at the end of the month to settle their debts. But let's say C here racks up thousands of dollars in debts but never turns up to clear his debt. So let's say A, B, C and D initially all put in $1,000 at the start in a pool, and my ledger would read something like A gets $1,000, and at any given point nobody can spend more than $1,000 or the money they have in the pool. So let's say at the beginning C has $1,000 in the pool. Now when he takes out $500 by either borrowing it from B, C or D, he could take out $500 at that point, and then this will be subtracted from here. That means he will only have $500 in the pool. Now if in the next time he demands $600, he cannot do that since his total will become negative. So this is called banning the overspending. Now this would guarantee that nobody overspends and nobody can run away with more money than they put in the pool. But there's still a problem. Let's say this entire ledger is being maintained over a website. What if the website someday crashes? Or it's an app which crashes? This ledger is lost and you won't know who owns how much money. So the person in charge has to be trusted forever, that he has to maintain his credibility and maintain the source of the ledger. This creates a huge problem. So how to solve this? So a solution to solve this is that A, B, C and D will all have their own ledgers. So whenever C borrows some money from A will broadcast this transaction to the entire network, and everyone will put in the line. What line? That A pays X money to C. So this is the kind of solution that solves the problem of decentralization. But still the problem is, let's say A has echoed the transaction and there are large number of people. Let's say A to Z, there are 26 people. Not only echoing is a problem, he also has to trust everybody, and everyone has to update their ledger accordingly. So how can A be sure that everyone updated their ledger, or how can everybody else be sure that A actually made this transaction? This interaction between the two parties is the main concern here. So now this is the problem that was originally addressed by the Bitcoin white paper. Well, to be honest, this is going far beyond what you actually need to know to invest in Bitcoin. You can obviously invest in Bitcoin without knowing any of this, but this is to understand how does Bitcoin actually work. So the solution the original Bitcoin paper proposed is that trust the blocks with the most computational work. Now, what is the computational work? Now that is the question. This question we'll start answering in the next part, and the next part along with it will also answer what is blockchain, what is the proof of work, what is computational work, what is mining, and other Bitcoin related facts. So if you've liked the explanation today and you understood what was the problem and challenge that made Bitcoin relevant, don't forget to leave the like, subscribe to the channel, and press the bell icon to know when the next video comes out. You can also comment your doubts below in the comment section below, and I'll address them. Thank you.